Welcome to part 4 of Competency 13. In this video, we will work with properties of regular polygons and circles. In this video, you really don't need to know all the names of all of the regular polygons. However, we will use the hexagon, hexagon and the pentagon. We won't use the heptagon, octagon, but for testing, these questions may be asked, and in most cases, you will not be given a picture if they want you to show that you know basic properties. Okay, before we begin, there's just a few terms that we need to refresh ourselves with, refresh our memory. So S will be side, N will be number of sides, P is perimeter, A is apothem, which was not a term when I was young. Okay, then you have perimeter will be equal to number of sides and length of side S. Okay, and there's just some images of the regular polygons and the inscribed and circumscribed circles that we'll work with. Now, really the main thing we're working with is area, which is the A and S divided by 2. Apothem divided by number of sides, apothem times number of side times side length, all divided by 2. Okay, let's move on to number 1. Number 1, if the radius is 15, what is the perimeter of the pentagon to the nearest hundredths of an inch? Okay, so this would be 15. And I know some other things about this. I know that this is a right angle. And I also know that if I go all the way around F, that's 360 degrees. So because I have 5 sides, if I take 360 and divide it by 5, I know the central angle is 72. And I need the angle of that triangle, the angle by F. So I'll divide that by 2. And that gives me 36. So I know that also here, I'll put an arrow. I know that's 36 degrees. Okay. And it says, what is the perimeter? So if I find this value of x, AG, we're just going to call it x. If I find that value, I know that I can just multiply that times 10 because there's 10 sections of that equal to that all the way around because it's a regular polygon. Okay, so unlike some of the books that you might get for practice study, I would prefer, which I'm going to use, the law of sign that you have or you will receive either on a practice test at the university or the actual TExES test, okay? It'll be on your formula sheet, so not a big deal. So you can know how to go access that. So what I'm going to utilize is the fact that we have sine of 90 degrees over 15 is equal to sine of 36 degrees over x. Now, there's something great going on here. If I put sine of 90 degrees in my calculator, it equals 1. Oh, and by the way, always check your calculator to see if it's in degrees, and ours is, so we back out. Okay, so I know this equals 1, which makes my life a little easier. So you have x equals 15 sine 36. We'll put that in the calculator, okay? All right, 15 sine 36. All right. And that is actually what x equals. Here, let's erase that and let's put that in. That is 8.81 817. Now let's multiply that times 10. Okay, times 10. And option A is our answer. Okay, let's go to number 2. Oh, let's leave some of this. So it looks like, yeah, number 2 has to do with number 1. So if the radius is 15 inches, what is the area of A, B, C, D, E above to the nearest hundredths? Okay, so we know that area is A equals ANS divided by 2. Apothem, number of sides, length of side, okay? And for our purposes, the length of the sides equals 2 times 8, 1, oh, sorry, 8 point. Okay, 8.1. Actually, let's see, we needed to round that. That would have been 817. Yes, 7.817. There we go. Okay, so we can put that in our calculator and get a rounded number. So let's just go up and grab it. Okay, push enter and then say times 2. So that gives us 17.634. I think that'll be good enough to use. Okay, now what do we really need to do? Let's redraw this triangle. Take out this section. There's our 90 degrees. We need to find A. Okay. All right. So how can we do that? You know what I need? Let's make this a little larger so we can really see what we're doing. There we go. This was 36. We know that this is 8.817. This is 90 degrees. Well, oh, and we have 15 right here. Well, if we know these two angles, two of the angles, then we know this third angle is 54 degrees. And we are looking for A. We need A. Okay? Well, let's just apply the same thing we did before and let's find the value of A. Okay? All right. So, yeah, let's go ahead and put 1 over 15. Okay, remember, sine of 90, it's our 90 degrees. Sine of 90 is 1 over 15. Now, let's use a darker color. 1 over 15 equals, okay, we need A, so A is going to be in our denominator. So then the degree measure we need is sine 54 will be our degree measure that we need to deal with. Okay. All right. So this gives us A equals 15 sine. Oh, it's getting to where we can't read it. Okay. Sine of 54. Okay. So now let's put that in our calculator and we have the value of A. So 15 sine 54 gives us A. Now we have something to work with. We can put that into our formula for the area that we have in this corner right here, and we're good. Okay? All right, that's 12.135. Okay, so what do we need? We need A equals all over 2. Okay, so we have A, that's 12.135, then times the number of sides, that's 5. You know what? Let me change to like a different color. Okay, times the 5 then all this over here. Kind of like I'm getting things in the way here. That's why I wanted to change color. But it looks like it's not going to matter. Let me squeeze this in. 12.135. I could do a better job, right? We have that times the 5 times the 17.634. We do all that, put all that in the calculator, then we should have the area. Okay, so let's give this a try and see if it works. Okay, all right, let's just put it all in at once. Let's go ahead and use 12.135 times 5 times 17.634, close parentheses, divide by 2. What do we get? And that's option D. Perfect. Okay, not bad. However, if you're not used to using some of the formulas I use, like using the law of sine, regular polygons, how to get the areas, how to use the right triangle, all these things, you might want to look at what I did again and practice and look these things up for yourself. Okay, now let's do number 3. If each side of a regular polygon is 3 inches, what is the area? I think we're missing a word there. What is the area to the nearest hundreds and centimeters? Okay, they mean the area of that hexagon. Okay, now here's the thing. I showed you shapes before. How many sides does a hexagon have? Okay, hexagon has 6 sides. Okay, I'll just put this right here. 6 sides. All right. So let's draw a triangle. That triangle section will be very helpful for us, okay? And we know that to get the area, we need A equals, same thing up here, ANS over 2. We know this is the right triangle. Now we have 6 sides instead of 5, okay? So that kind of changes things. So let's say 360 divide by 6. Okay, that's 60 degrees. But we need this top one here. We need this one, this angle right here. Okay, so we're going to take that and divide by 2. So what are we going to get? We get 30 degrees here and 60 degrees here. Okay, that's what we have. Well, that's kind of a good thing because now we can use our laws of sine and go through the motion and find everything we need. Okay, across from here, now they said each side is 3 inches. It says each side of the regular hexagon. So this little section is 1.5 and this little section is 1.5. Okay, so this is what we need. We need, scoot this up. Okay, what we need is, we can't use our 90 degrees, but we need the apothem. We need A right here. Okay, so we have the sine of 30 degrees, and that is across from 1.5, and that is equal to the sine of the 60 degrees over the A. All right, great. So go through the motions. So we have sine of the 30 degrees, A is equal to 1 1.5 sine 60 degrees, okay? And that is all over, well, we have to divide by the sine of 30 degrees on both sides. And we know that will equal A, okay? Because this cancels out. Right, and then once we get that, we can go through everything and find out what our A equals, okay? All right, well, we do know a few things. Well, let's look at what we do know. We know that each side length is 3. We know we have 6 sides. And we know we have to multiply by A and divide by 2. Now, you can go ahead and say, well, we can cancel. So if we take 3 times 6 is 18, 18 and divide by 2, we actually know that the area is 9A. Well, that's going to make things pretty simple. Let's go find what A is. We have it right here. Here we go. There's our A. So 1.5 sine of 60, okay, and divide all that by sine of 30. Let's see if I put it in correctly, equals. And that is correct. That is our value of A. So all we have to do now is just multiply that times 9, times 9. And we have it. Option C. Great. I'm going to go ahead and jot in what that is. 9 times 2.599, somewhere in there. Okay. All right. If you can see that's the decimal. All right, let's move on. Number 4, if the area of the circle is 25 pi, what is the perimeter of the pentagon to the nearest hundredth of an inch? Okay, well, FG is our radius, and 5 times 5, remember, it would be r squared times pi. So that tells me that FG, our radius, is equal to 5. But we need to find x. Well, which is fine because we already know some things about our triangle of our image. We know that this angle is 36 degrees, and we know that this angle is 54 degrees, and we know that we have 90 degrees there. Although in this case, a 90-degree angle will do us no good because we're not looking for that radius of the pentagon. We have the radius of the circle, so we're not looking for that particular side length. Okay, so what do we need to do to find x? Well, it's what we've been doing. We need the sine of 36 over x is equal to the sine of 54 over 5, okay? All right. So now we just cross multiply and go through the algebra. Okay, so sine of 54x equals 5 sine 36. Divide both sides by the sine of 54. Okay. That means, I'm going to go back to that blue color I had. Well, it doesn't matter. Okay, that means that cancels out, and we can find the value of x, okay? Let's put that in the calculator, all right? 5 sine 36 divided by sine 54, enter, yeah, and that equals just, well, let's do a approximate, not equal, 3.633, but we don't even really need to do any rounding. Take what you have in your calculator, multiply times 10. And that is option B. Now, how did I know that I needed to multiply times 10? That's because we worked with this triangle. Let me highlight. Okay, we were working with this triangle and this one section. If we look around our shape, we see that we have 10 of those, all congruent. And remember, this only works with a regular polygon, okay? Regardless of the number of sides, it must be regular. If it's irregular, then none of our methods that we're using will actually work. That's a whole other thing. And it's highly, highly unlikely you're going to see anything like that on a test. Now, if I find that you will, then I'll come back and add to this later, but I have yet to see that happen. Okay, number 5. If the perimeter of ABCDE is 80 inches, what is the area of the circumscribed circle to the nearest hundreds? Okay, that's circle. So in this case, we have our R, and that is important. But we can find quite a bit, okay? And we need to find R, right? And we know that this is 90 degrees. And this is 1, 2, 3, 4, 5 sides. So it's what we were doing before. That tells me that I have 36 over here and 54 degrees here. Very convenient, okay? So for our purposes, we need to find the area equal to R squared pi. All right? All right, so the first thing that we need to do is we need to find, well, we need to take 80 and divide that by 10. Remember, we just said we had 10 little equal pieces around? Well, 8 divided by 10, well, what does that tell me? That tells me each of these lengths is 8, okay? And then if we divide that by 5, we have 16. Each side is equal 16 units. Okay, so that's very helpful. All right, so what are we going to do? We need to say sine of 90 degrees over R equals, okay, sine of 36 degrees over 8. Well, yeah, that's very convenient because we can mark this out. It equals 1. Okay. Sine of R and yes, 36. I was just double checking. All right, so what do we have? We have sine of 36R equals 8. Then if we divide both sides by sine of 36, okay, we mark that out and we put this in our calculator. Oh, okay. Let's grab another color. Put this in our calculator, and that will give us R. And then we can square that and multiply it times pi. And they're asking for decimal answers, so we should be good to go. Okay, 8 divided by sine 36 equals. I'm going to go ahead and write that down. 13.61. Let's square that and times second, caret up for pi. And that's 581, rounded a little. Oh, looks like our rounding was a little off from what they gave us. But A is our option. We have a rounding error. That's going to bug me. But you know why I think it does? Let's put in 13.61, square that, and then make that times second caret up pi. Yeah, that's where it is. It's the difference of using the calculator value versus the rounded value that we wrote down. Perfect. All right, let's go to number 6. Number 6. If the radius of the circle is 4 square roots of 3, what is the perimeter of the hexagon Hijklm? It's a mouthful. Okay, so I see 2 ways to do this. I see the fast and easy way out, and then also working things out. So let me show you the fast and easy. I'm going to take my triangle. Well, I know that this will be my 90 degrees. I know that this is 30 degrees. And I know that we have 60 degrees. Okay. And I am looking for the value of x because they want the perimeter. All right. So that's a special right triangle. And for this right triangle, again, 10. It would be really nice if my technology would work. Now it's working. Crazy. All right, well, interesting. Okay. I don't know if this is going to be any better. Okay, so I have in my brain, I know that I have x, 2 times x, and x square roots of 3. That's a 30, 60, 90 triangle. Okay. And that's like the base of it. That's like a rule, a property. Okay. So if you tell me that this radius is 4 square roots of 3, I know that my x, will equal 4. And then I also know that I need 12 of those because this is a 6-sided and 4 is half of the length of each side. So 4 times 12 is 48. So I am saying that B is the option we need. But just in case you don't believe me, you're just like, what on earth are you talking? I've never seen these special triangles. Where are you getting this from? Well, that's not a problem. Let's go through the process that I've showed you and let's double check my calculations. Okay, so what do we need? Okay, we need that. We need the sine of 30 over x, and that is going to be equal to the sine of 60 over our 4 square roots of 3. Okay, all right, so we have the sine of 60 x equals the sine of 30 4 square roots of 3. Yeah, I kind of wrote that backwards, but it doesn't matter. Okay, so let me rewrite it. What will that give us? That means we need x equals 4 square roots of 3 sine 30 all over sine of 60. Okay, see what I did? I just rewrote it. We divided both sides by sine of 60. Okay, now let's put that in the calculator. All right, 4 second square root 3, scoot over. Notice how I arrowed over. Sine of 30, I have a parentheses here. Sine of 30, close your parentheses, divide by sine of 60, and I like to close my parentheses, and that equals 4. So that verifies that we needed, to go all the way around our perimeter, we needed P equals 2 times 4 times 6. Okay, and 6 times 8 is 48. Okay. Notice how knowing the properties, I could get that through that very quickly. But if you can't remember the properties, you don't know them off your top of your head, you do have a formula sheet that is given to you. You could utilize that formula sheet and be just fine. So, there's more than one way. There's always more than one way to do things. It's just a matter of what do you remember at the time? How well versed are you at one thing or the other? Okay, now, if the area of a circle is 144 pi, what is the length of the apothem of Hijklm to the nearest hundreds? Okie dokie. So I know that the area is 12 times 12. Yeah, right. We know that would be 12 squared pi. So that tells me my radius is 12. Okay. All right. Now we can apply special triangle rules again, and we will solve it the other way again. I know. Let me write my special triangle here. This 12 is 2 times 6. That tells me that down here, this length is 6, and my apothem has to be 6 square roots of 3. And I see my answer. Okay? Now, that's one way of knowing that if you see this on a test or a practice test, that they're testing to see the person that gets done quicker and accurately will know properties. And there's more properties. And I've noticed that when I'm taking the practice test and doing other things in my classroom, I can see things because I know properties that students haven't learned yet. And I'll say, oh no, I see what you've done now. This is this. That's kind of what this is about. But we can solve it the other way, okay? And we have the luxury of using our 90 degrees. So sine of the 90 degrees, which we know is 1. Oh my goodness. I don't know if that looks like a 1. We know that equals 1. How about that? Over the 12, which equals, okay, what are we looking for here? We are looking for the A, and we need this. Actually, let me bring it down better so we can read it. We need this angle measure. Do we remember what that was? Well, if you don't, it isn't a big deal. You have 6 sides. So you take 360, divide by 6 like we did before. Okay. Now, if we divide, actually, it's 60 because it's just coinciding that creates an equilateral triangle. Okay. Okay. This is 60. This is 60. And 60 is the one that we're working with, okay? All right, so that tells me we need sine of 60 over the x. I don't know. Actually, not the x. Let's use a. Over the a, I don't know. Apothem, I want to find out. Okay, so that means we have a equals sine of 60. Did I do that correctly? Yes. Sine of 60 times 12. That's okay. And then if we put that in the calculator, we should be fine. But we're going to run into an issue, and I'll show you in a sec. 12 sine of 60. Well, that's going to give us a decimal. And our calculator will not give us terms in square root. Okay, now there are some calculators that will, the TI-84 will not. Well, how do we know if we're correct? Well, easy enough. We could, now watch, this is a trick, okay? We can just take divide second divided by the square root of 3. When I push the button, we should see the number 6. Bam. So we know that this equals 6 square roots of 3. Okay? All right, that's the last question in this video. Once again, thank you so much for watching. And please, don't forget to like us, share us. Please share out to people that you know are studying. That'd be great because we need subscriptions. The more, the merrier. And happy testing.